Hey guys, in this lesson we would understand the difference between y is equal to x square and y is equal to 2 to the power x relation. We know y is equal to x square is a parent relation for quadratic equations or quadratic relations that we have covered up in the previous lesson. Therefore, y is equal to x to the power of 2. Here base is x and power is 2. This is called a parent quadratic relation, whereas y is equal to 2 to the power of x. Here the base is 2 and power is x. This type of relation is called exponential relation. Exponential relations are very different from quadratic relations because their graphs are different. Their characteristics are different. Their table of values are different. Let's compare these two relations using table of values first. We know x, no matter if you're taking quadratic relation or exponential relation, x is independent variable and y is dependent variable. So the independent variable values depend upon us. We can take whatever numbers for independent variables as we want to put in the table of values, whereas the value of y will depend upon the relation it has with x. So here y is equal to the square of x, whereas in exponential relation y is equal to 2 to the power of x. We would take x values from -3 to 3 just to have sufficient values in the table to compare them. So if we take x as -3, -2, -1, 0, 1, 2, 3. Here also we'll put x as -3, -2, -1, 0, 1, 2, and 3. Now because x to the power of 2 gives us a y, so here x is a -3. -3 to the power of 2 means -3 is squared, so this would give us a 9. Similarly, -2 to the power of 2 will give us a 4. -1 to the power of 1. -1 to the power of 2 would give us a 1. 0 to the power of 2, so 0 raised to the power any number is a 0. 1 to the power of 2 would give us a 1. 2 to the power of 2 would give us a 4. And 3 to the power of 2 would give us a 9. So these are the respective y values for these x values. Now because exponential relation is y is equal to 2 to the power of x, so the variable will change here. So 2 to the power of -3, which is, when we put this on the calculator, we would get 1/8. So this gives us y value equal to 1/8. Similarly, 2 to the power of -2 would give us a value of 1/4. 2 to the power of -1 gives us 1/2. 2 to the power of 0, any number raised to the power of 0 is always 1, so this would give us a 1. We can put all of these values on the calculator. 2 to the power of 1 on the calculator will give us a 2. 2 to the power of 2 on calculator will give us a 4, and 2 to the power of 3 on the calculator will give us an 8. So when we look at the values, they are way too different from each other. This shows that y is very different when it comes to exponential relation compared to quadratic relation. Now we would turn these table of values into a graph. So we mark on the x-axis -3 to 3. Here also on the x-axis we will mark -3 to 3 numbers. If this is the grid, here we notice when x is -3, y is 9. So when x is -3, y is 9. When x is -2, y is 4. -1, y is 1. When x is 0, y is 0. Similarly, when x is 1, y is 1. X is 2, y is 4, x is 3, y is 9 again. When we join these points, we get a graph called parabola. We have already looked into the graph of parabola in the previous lesson as well. Now let's see how the graph of exponential relation looks like. When x is -3, y is 1/8. That's a very small number. It's going to be 0.125. So let's say the point is somewhat here. Similarly, when x is -2, y is 1/4, which is 0.25, which is a little bit over than the previous 0.1/8. This would be here. When x is -1, y is 0.5, that would be here. When x is 0, y is 1, that's here. When x is 1, y is 2. When x is 2, y is 4. And when x is 3, y is 8. So this is how the graph of an exponential relation would look like. Even if we extend the x values, both on the left and the right side, the graph's shape would look exactly how it looks here. So this would be just a little bit extended. This would look like extended here and extended here. However, the shape would be exactly same as what it is that is being seen here. One thing here to remember is that for exponential relation, the y values are not going to be equal to negative values. So this white graph is not going to cross the x-axis and come underneath the x-axis. It will always stay above the x-axis. So this is how the graphs of exponential and quadratic relation would look like. Therefore, we can conclude y is equal to x squared is a different parent relation called quadratic relation, and y is equal to 2 to the power x is a different parent relation called exponential relation, because they have different values of y for different x values and they have different looking graphs. Whenever the graphs are different, that means their characteristics, their features would also be different.